right, remember that 8JP, you guys are listening for names of individuals like pond, and then 8ZA, you're listening for jobs. So make sure you pay attention to see who's going to go on Friday. Okay, this is the worksheet answers. You'll notice number 17, I didn't fill it in. We can talk about that if you'd like, but I'm not too worried about it. So pause it and see what you got right and wrong. Bring it with you to class on Friday. Okay, just like ecologists enjoy Friday because it's almost the weekend. So, right. All right. Jaja, I'd like you to learn about geometric sequences. If you remember a chapter ago, we talked about arithmetic sequences. And we've dealt with two words, recursive and explicit. This is information that bank tellers know how to use. So that is a good thing. Okay, so let's look at what you see up here on the screen, how we determine the starting value is A, and how a common ratio, this is now multiplication. Remember, this is what the recursive definition looks like. So you can see that, and we're just going to kind of fill in parts that we need to. And then the explicit definition is only one formula. This is actually the best way, when we're talking about explicit, to find like a missing value. Let's say we want to find the 11th term in the sequence. We can use the explicit. It's good for the nth term. Okay, so you might want to remember that. Every geometric sequence has a starting value and a common ratio, so those are the two things you need. They define a unique geometric sequence. So as you look through these, each one will be unique based on its starting value and the ratio. Okay, the first type of problem asks you to find whether it's a geometric sequence or not. And the idea, Ming, is to determine if there is a common ratio, if it's being multiplied. So here we see we're multiplying by 10, 10, 10, 10. But here we see that we're multiplying by 2, and then 1.5, 1.33, 1.25. And every organic chemist knows that that is not the same number. Okay? So therefore this is not geometric. Okay, this one is not. So let's look at these ones. I'll do the left-hand column. You do the right-hand column. We are multiplying each previous number by 2. So we're times 2, times 2, times 2, times 2. So therefore this is geometric. It does follow the principle of a common ratio. Now it doesn't always have to be whole numbers. Look at this, 1/3 times 1/3 gives me 1/9. 1/9 times 1/3 gives me 1/27. And this is times 1/3 as well. So that is also geometric. Go figure that one out, Chewy. That's right. Or should I say Chuji? Sorry. Okay. Okay, so now do these two, and if you want, you can find the answers in class on Friday. All right, recursive and explicit. So we start with the formulas here, and we just fill them in. So A1 is 7, so I write that. A sub 1 is equal to 7, and then all of this stuff stays the same, except for R. I write it in as 3. So therefore there is the recursive formula. This is the explicit. Remember, it's the one we use to find the nth term. So I'm going to fill this in. A sub n, A sub 1 is 7, R is 3 to the power of n minus 1. Okay. So physical chemists figure this stuff out all on their own because they're smart. Okay. All right, down here, I'll do this one for you, and then you can do B on your own. So we're going to write out the recursive formula. We need to name what a sub 1 is. That's the first value in the sequence. And then we start with a sub n is equal to a sub n minus 1 times the common difference, which in this case is 2. Okay? And then we follow this format. A sub n is equal to the first term of the sequence multiplied by the common difference, which we found already, to the power of n minus 1. So there's the recursive, there's the explicit. Your turn. Okay, one slide left. This one takes it a little step further. Okay, you'll notice it also asks for the 8th term. Not only are we giving the recursive and the explicit formula, but now we're giving the 8th term of the sequence. Right now we only have 4, right now we only have 4. So you could continue the pattern and find it that way, but what happens if this said the 88th term? Okay, so that's where this U comes into handy. Okay, recursive. We name what a sub 1 is, and then we have a sub n is equal to a sub n minus 1 times the common ratio, which in this case is 6. We can find the common ratio by taking the second term divided by the first term, the third term divided by the second, the fourth divided by the third, and so on. Okay. Now, the explicit formula, a sub n is equal to the first term. Oops, sorry, that's not what I meant. Where is it? There it is. Okay. The first term, which is 14, multiplied by the common ratio to the power of n minus 1. And then we plug in an 8. So we get 14 times 6 to the power of 8 minus 1. So a sub 8 is equal to 3,919,104. Go figure that. I don't think any of the jobs or the people that I've labeled will make that much money in a year. So, okay. Do this last one. You need the recursive, you need the explicit formula, and then you need to figure out what the 8th term is. That's the video. That's the chapter. Hopefully it's worked out for you. We do have a review day on Monday, so you can save some questions that you need to right before the test on Wednesday, February 5th. Remember, that's the test date. All right, I'm out.